session. This is Xin Yi from Tsinghua University, China, on behalf of colleagues from Tsinghua and the University of California, Santa Barbara. And this is a video presentation of From 2D to 3D, facilitating single-finger mid-air typing on QWERTY keyboards with probabilistic touch modeling. What's that?
First of all, I would say sorry to all of you for my absence of the offline conference due to some user issues. Here, I would like to present a paper, From 2D to 3D, facilitating single-finger mid-air typing on virtual keyboard with probabilistic touch modeling. Thanks for my collaborators, Xin Yi, Haozhan Chen, Jiuxu Chun, Hewu and Yuanchun for their valuable effort put into this work. Let's first watch an introduction video of our paper.
In this paper, we demonstrated the feasibility of efficient single-finger typing in mid-air. To enable efficient input experience, we derived an input prediction algorithm that incorporated probabilistic touch detection and elastic probabilistic decoding. We evaluated the performance of our optimal technique in a text transcription task with 3 baselines: Vulture, a single-finger gesture typing technique in VR, and 2 techniques derived from our optimal technique with replaced collision-based tap detection and rigid input prediction algorithms, respectively. The users typed 26.1 WPM using our technique, which was significantly faster than all the other baselines.
Then we come up with the research background. Touch input is the most prevalent input modality in virtual reality. However, touches in mid-air lacks tactile feedback, which not only impedes the certainty feeling of the user, but also yields more noisy input data. Traditional virtual interface recognizes touches simply by detecting intersections between the finger and the plane, which yield more errors and is not capable for interaction tasks requiring dense touch input, such as text entry. For example, in this video, when typing with the default HoloLens keyboard interface, the user should carefully control their input behavior to achieve accurate tap input. Previous researchers investigated different techniques for mid-air text entry, such as mid-air pinch-based retro typing and mid-air 10-finger typing. Although these techniques could achieve competitive input efficiency, they also have relatively greater learning cost. So we may ask, can we achieve efficient mid-air text entry with the most intuitive single-finger tap-based typing method that requires minimal prior knowledge of the user and introduce little learning efforts? So how can we improve the algorithms for efficient single-finger mid-air typing? In this paper, we targeted on this question, and our finding is that the algorithms can be improved with either an improved tapping detector or stronger statistical decoder with error tolerance and probabilistic touch modeling. We first conducted a user study to investigate the user's single-finger mid-air typing behavior. We recruited 12 participants to accomplish text transcription tasks on 3 levels of keyboard sizes in a fast and natural manner. We collected touch data of different keyboard sizes and manually labeled the touches with the corresponding characters from the raw typing data according to the log data and the recording video. We analyzed fingertip trajectories of single-finger mid-air typing, including the fingertip velocity, amplitude, and tapping angles. An important finding is that about 20% of all taps did not intersect with the virtual plane when the users were told to type naturally, which validates the obligation of an improved touch detection model. Regarding the user's aiming strategy, we found the lowest vertical tip aiming model was shown optimal to fit the user's mental model by yielding the smallest standard deviations of the projected touch points on the virtual keyboard. We also find a larger offset and deviation of touch points in z-axis. Based on these findings, we trained a support vector machine, or SVM-based model, with RBF kernel to detect the touch points from the continuous input data, achieving an F1 score of 97.7% for touch prediction. To compensate for the imprecision in touch detection and touch point location, we proposed a novel input prediction algorithm that incorporates the uncertainty in tap detection into an elastic probabilistic decoding algorithm and treated false detection as insertion and omission errors. We ran a full-factorial simulation on geometry model, tap probability, language model, elasticity, and tap detection model to evaluate our algorithms. Results show that the SVM-based probabilistic touch detector together with an 2D elastic probabilistic decoding algorithm with an elasticity of 2 to achieve the optimal top 5 accuracy of 94.2% on a 10,000-word dictionary. In the second user study, we evaluated the performance of the proposed techniques in a text transcription task with 3 baselines. 2 of the baselines are the ablation settings, with the removal of the elastic decoder or the touch detection model respectively. The third baseline is the voucher, which is a mid-air gesture typing with a baseline with strong reported performance. Our results show that the user typed 26.1 WPM using our technique, which was significantly faster than all the baselines. Expert users could even achieve 36.8 WPM. Compared with the 2 tap-based baseline techniques, our proposed techniques led to fewer strokes for correcting errors and more confidence during tapping. Therefore, it also received the highest preference score in all dimensions in our subjective ratings. As the conclusion, our work is the first to explore the feasibility of efficient single-finger mid-air typing using probabilistic touch modeling. Our results demonstrate that efficient text entry in mid-air was achievable, and single-finger typing was potentially preferable despite the absence of tactile feedback. Further discussions on modeling typing behavior in mid-air typing and facilitating more efficient and pervasive mid-air text entry are presented in our paper. That's all for my presentation. Thanks for your attention. For more details, please refer to our paper. I'm happy to take your questions or any further discussions, probably in the Wall app or through any online forms.